Okay, so we'll try this again. Chapter 7, Section 4 is called Special Right Triangles. You're going to learn about 2 different special right triangles that have a relationship, length of the sides, and the first one is this, 45, 45, 90. So in a 45, 45, 90 triangle, and what that means is that it's a right triangle, that's isosceles, right? 45, 45 means that they would both be the same. Base angles theorem tells you if the angles are the same, then the sides opposite them are the same, or the base angles converse. So the relationship between the sides of a triangle, that is a 45, 45, 90 triangle, would be A and A, which is going to be a value, for the 2 congruent legs. And then the hypotenuse is that value times the square root of 2. So it's A, and then A root 2. So that if this side was given, if I told you that the side where the A is was 8, let's say, then I would automatically know all of the other lengths of the sides of a triangle. So the special right triangles tell you that I only need one side length to find the other 2. I would know that if that's 8, then this is 8, and this is 8 root 2. So the square root properties are still staying with us. We're still going to have to simplify sometimes. Okay? But the idea is that no matter what the lengths of the sides, the ratio is always true. So if I drew a teeny tiny isosceles right triangle and asked you to find the lengths of the sides, and then I drew a huge right triangle, isosceles right triangle, and asked you to find the lengths of the sides, the lengths themselves might be the same, or different, sorry, but the ratios would be the same. They would all be A, and A root 2. So we start with just the 45, 45, 90 triangle. This time, what's given to you? The hypotenuse. So if this is supposed to be A, and this is supposed to be A, and this is supposed to be A root 2, then instead of being given the A, I have to find out what A would be. So I just say, okay, if 6 equals A root 2, how would I solve this for A? I want to get the A by itself. How would you get the A by yourself? Nope. You could, but it's harder than it needs to be. Divide by the root 2, right? We're just multiplying there. So I just want to get rid of it by doing the opposite, which would be dividing. So I'm going to divide both sides by root 2. These are going to cancel, and I get A equals 6 over root 2. So I got given this side, right? So I label it every time. I like A, and A root 2. And then whatever side you're given, if I'm given the A's, then it's easy. But when you're given the A root 2, I would say that if 6 equals A root 2, I have to solve for A. I got to figure out what A is. So this is multiplication, right? This is A times root 2. To do the opposite would be to divide by root 2. Okay, which is where we're at right now. But if you remember, you can't leave a square root in the denominator. Do you remember this? From algebra? Okay, so you can't leave a square root in a denominator. The square root's an irrational number, and it can't be left in the denominator. So we do something called rationalizing a denominator. And that means I multiply both the top and the bottom by whatever's in the bottom. So if I come over here, I multiply both the top and the bottom by the square root of 2. And I can do this because I'm basically multiplying by 1, which doesn't change it. And then in my numerator, I would get 6 root 2. And in the denominator, I get root 2 times root 2, which is what? 2. So the whole goal there is to get rid of the square root in the bottom. Nope. Can this be simplified? Yes. Because I have 2 numbers on the outside of the square root that are both divisible by 2, I can simplify this. So A would be 3 root 2.
Did you ever simplify what's under the radical sign?
Yeah, but most likely if it's like a root 4, it won't be something that can be simplified. It is possible, but most likely it won't happen. So what this tells me is, what is 3 root 2 in my triangle? Both of these sides, right? So you're dealing still with a lot of properties of square roots, and now we're mixing it in with these special right triangles. Okay, second special triangle is a 30, 60, 90 triangle. So this is a right triangle. They have to be right triangles, so you have to have a right angle, in which one angle is 30 degrees and the other angle will be 60 degrees. God bless you. And the relationship here is opposite the 30 is your A. So you're going to locate your 30-degree angle, and opposite goes your A. Opposite the 60 degrees is A times the square root of 3. And then opposite the 90 is 2 times A. So the setup of it is sheer memorization. You have to know those relationships. And then comes the application of it. If you're given a measurement, how do I find the other ones? So 45 is A root 2. 30, 60, 90 is A root 3, and 2A. So if I had asked you to put the side lengths in order, do you remember how you figure out which one's the smallest? How do you know which side is the smallest in a triangle? Opposite the smallest angle. What's the largest one? Opposite the largest. And the middle one would be in between, right? So think about what is square root 3. Let's approximate it, right? It's in between what two perfect squares? 4 and what's the perfect square smaller than 3? 1. So it's in between 1 and 4, right? Which would be square root 1 would be 1, square root 4 would be 2. So that number is somewhere in between 1 and 2. You following me? So let's say it's 1.7, something like that, right? We're just approximating it. So this is like saying I'm going to take the A and I'm going to multiply it times 1.7. So now your side length should make sense, right? A would be the smallest, which is opposite the 30. 1.7-ish times A would be the middle, which is opposite the 60. And then 2 times A, which is the largest, would be opposite the 90 degrees. Okay? So if you get confused and you forget what goes across from what, try to think of it that way. Opposite 30A, opposite 60, A root 3, opposite 90, 2A. Okay, apply it just like we just did. Do I have to know what that third angle is in order to know that this is a 30, 60, 90 triangle? No, why not? As long as I have the 90 and the 60, I know the other angle has to be 30, right? Because if it's 90, the other two have to add up to 90. Take away the 60, I'm left with 30. So you will see at least the right angle and one other angle given to you, okay? But it might not always be the 30. It might not always be the 60. So now set up your relationship. So opposite the 30 goes what letter? A. Opposite the 60 goes what letter? A root 3. And opposite the 90, 2A. God bless you. So these are the easy ones. They gave me A. If A is 5, and I plug that 5 in the place of here, then what is X? 5 root 3. And if A is 5, and I plug it in the place of A, then Y is 10. So these are the easy ones, the ones that they give you the A, right? Because then you just have to multiply it. Then you're going to start to see a little bit more application on here, so they're not such straightforward. This one says the diagonal of a square has a length of 6. What's the perimeter of the square? So start with square. Give yourself the visual. And the diagonal of a square. Okay, and we've talked about this before. What do we know about the angles inside a square? They're 90 degrees. So this is 90, this is 90, this was 90, and this was 90. And then we just cut it with a diagonal. Okay? What do we know about the sides of a square? They're all equal. So I have two isosceles triangles here, which means they are two what triangles? 45, 45, 90 triangles. So as soon as you see square and diagonal, think 45, 45, 90, okay? So now give your side length. So the relationship between this triangle, so I'm just going to use one side of this. What goes where? A on the legs, so opposite the 45s are the A's, and opposite the 90 or the hypotenuse would be 2, square root of 2 times A. So now if they had asked for or if they had given me the leg and asked for the hypotenuse, it would be easy, right? If I told you the leg was 3, what's the hypotenuse? What would be your answer? 3 square root 2, good. But this time it's a little bit trickier because this time they're giving you the actual diagonal is 6. So we just did this example, but think about how you did it. We said, okay, if A root 2 equals 6, then to get A by itself, I'd have to do what? Divide by the square root of 2. It's going to cancel here. A equals 6 over root 2. And then that root 2 can't stay in the bottom, so what do I multiply by? Root 2 over root 2. And A equals 6 root 2 over root 2 times root 2, which is 2. And then I can simplify. So obviously they're not all going to be 6, but the process is the same. So that tells me that this side length is 3 root 2 and this side length is 3 root 2. What's the question asking? What's the perimeter? How do I find the perimeter of a square? And there's 2 answers to that question. What's one way? How to find the perimeter to any shape? So a square, I'd multiply one side by 4 because they're 4 of the same, right? Any other shape, you would just add them up. So I could say 3 root 2 plus 3 root 2 plus 3 root 2 plus 3 root 2. Or I could say 4 times 3 root 2. So with square roots, if there's 2 numbers on the outside, I can multiply them together. So this becomes 12 root 2. If I'm adding, then the root stays the same, and I add the coefficients on the front. So it would be 3 plus 3 plus 3 plus 3, or 12 root 2. Okay, this one says an equilateral triangle has an altitude length of 5. Find the perimeter of the triangle. So start with a triangle. What do we know about an equilateral triangle? The sides are the same. And what do we know about the angles? They're all the same. So if I have 3 angles that are all the same measurement, what do they equal? 60, right? 180 divided by 3. Everybody good on that? So this would be 60, this would be 60, and this would be 60. What's an altitude? Vertex to the opposite side, and it's got to do what on the other opposite side? Form a right angle. And then somebody said too, it splits that into 2 congruent parts. Okay, that's also true. So if I just made this a right angle and this is 60, what happened to my top angle? It become 30 and 30. It got cut in half. Because the altitude in an isosceles triangle is also the angle bisector. It's also the median, right? It was all those things, perpendicular bisector. So an equilateral triangle with an altitude is the same thing as 2 30, 60, 90 triangles. So I'm just going to draw one so you can kind of just focus on one for now. This is 90, this is 60, this is 30. So I just redrew the triangle on the right. Alexis.
Would you have to add the sides of it, the angles in the inside to make sure that it's right? Or?
No, if you have an equilateral triangle with the altitude, it's cutting it into half. Because the altitude has to be a right angle. the right angle on the side, or the side that's located on the right, is 60 degrees because it's equilateral, which leaves only 30 for the top. So now it says the altitude is 5. So if this is my length of 5, then this is the 5. And then set up your relationship. So in a 30, 60, 90 triangle, what goes opposite the 30? A. What goes opposite the 60? A root 3. And opposite the 90, 2A. So it just got a little uglier, because now I'm not given the A, I'm given the A root 3. So I'm going to do the same thing we just did in the last example. I'm going to say, okay, if A root 3 equals 5, then I need to solve this for A. How do I do that? Divide it by root 3. Can I leave it like that? Nope, I got to rationalize it, which would be multiplying by what? Root 3 and root 3. So this becomes 5 root 3 over 3. Can that be simplified? No. So it's actually going to stay as a fraction. You with me so far? So that is 1/2 of the bottom side. If I wanted to find this full side, which is opposite the 90, I have to do what to that? Multiply it by 2. So 2 times 5 root 3 over 3. This would be 2 over 1, and this becomes 10 root 3 over 3. Correct. Unless you're multiplying a radical times a radical. So it was root 3 times root 2, root 6. But you're not going to get to that in here. Okay, so but that's one side length, right? What's it asking for? The perimeter. So what are 2 ways to find the perimeter of an equilateral triangle? Multiply by 3 because they're all the same, or add 3 times. So 3 times 10 root 3 over 3 is going to give me the perimeter. And then 3 over 1 times 10 root 3 over 3, I can actually cancel out these 3's. And I get left with 10 root 3. Or I could have multiplied it, I get 30 root 3 over 3, which then reduces back to 10 root 3. I like to make my numbers as small as possible, so I just cancel as I go. Alexis.
Why did you do times 10 root 3?
So the 10 root 3 is the whole side. The 5 root 3 was just half of it. And then I want to find the perimeter. So it's equilateral, which means they're 3 of the same side lengths. I do 3 times that 10 root 3 over 3. Questions? That the 10 root 3 is the answer. This is your perimeter. Wait for it. Wait for it. Wait for it. The TV's frozen.